Hello, this is Joe back with another video. It's been a while since I made a video. Just haven't had the time working and whatnot. But I thought I'd do a video on aircraft engines, the different types, different piston engines for different airplanes, as well as gas turbine engines. Piston engines for small airplanes and some big ones pretty much operate the same way they do in your car, with the piston going up and down, connected to a crankshaft, which turns the transmission in your car. Except in this case, the crankshaft is connected to a propeller, and as the propeller spins, it creates forward thrust. The propeller blades themselves act like mini wings, pulling the aircraft forward instead of up. Different propellers have different number of blades and blade length, depending on the engine power and the aircraft and what's required. Most small general aviation aircrafts have cylinders aligned horizontally, opposed, whereas in your car the cylinders are either straight in a line or in a V shape, like a V6 or a V8. And almost all aircraft engines are air-cooled, with the incoming air flowing over the cylinders to cool it down, so they don't have a radiator or water pumps or anything like that. But they do have an oil cooler. There are some aircraft engines that are water-cooled with a radiator and a water pump and all that, but they're not all that common. But some World War II aircrafts had them, like the P-51 Mustang. Some of the more modern general aviation aircrafts will have that. And some engines are even diesel nowadays. They can actually just run on jet fuel as opposed to aviation gasoline. A lot of World War II aircrafts, as well as older prop liners, airliners from the 40s and 50s, will have what's called a radial piston engine. In this configuration, the cylinders are aligned around the crankshaft in a ring formation, and all these engines are air-cooled as well. And a lot of them would have superchargers installed on them to boost the horsepower, really pushing that technology really to the limits for that time. Some of these engines, such as the Pratt & Whitney R2800, had a wide range of horsepower depending on the variant and the turbochargers and superchargers installed on them. Once mounted to the aircraft, somewhere between 1,500 on the low end to 2,500, close to 3,000 on the high end horsepower. All of the Navy World War II aircrafts pretty much exclusively used radial engines. The basic process of any internal combustion engine is sucking in fresh oxygen, mixing it with fuel, compressing it, igniting it. The hot gas expands, basically like an explosion, and pushes the piston down, turning the crankshaft, and then as the piston comes back up, it expels the used gas, otherwise known as exhaust. That's the basic process of a four-stroke piston engine. There are two-stroke piston engines, but they condense a lot of that process into two strokes. But those engines are not very efficient. Here's an animation showing the basic process of how it works. Now, when it comes to jet aircraft, the propulsion doesn't come from a spinning propeller. Instead, it comes from hot exhaust being jettisoned out the back, propelling the aircraft forward. These are called jet engines, or gas turbine engines to be more accurate. Rocket engines operate on the same principle, except they carry their oxygen on board internally, which allows them to operate in low oxygen environments such as outer space. Corporate jets like this would use a low to medium bypass turbofan engine such as this one. Almost all modern regular airliners would use a high bypass turbofan. This is one on a test stand. This is a cutaway image of what the internal engine would look like. This is a diagram of the basic components of a jet engine. You have the intake fan, the compressor fan section, the combustor, the turbine section, and then of course the nozzle. Here's another short animation of how a jet engine works, more or less. Now, a gas turbine engine works on the same basic principles that the internal combustion piston engine operates on. It sucks in air, it compresses it, it ignites it, the gas expands, you get your power off of that, and then it's exhausted. In a gas turbine engine, as the gas expands after it's ignited, it passes through the turbine section. The turbine fans are connected to the compressor fans and the intake fans. And as long as there's fuel still going into the engine, this process continues. Now, in a gas turbine engine, it does have igniters, a little bit like spark plugs, but they're only used for the initial start of the engine. After the engine is started, the igniters are turned off, and then the fire basically just keeps going, and it blows on the turbine section. And the turbine section turns the compressor section, which sucks in air and compresses it, keeping the whole process going. The gas is expelled out the back. And this, of course, propels the engine forward and thus the aircraft. For every action, there's an equal and opposite reaction. These are known as reactionary engines. You can see this on a smaller scale. If you've ever inflated a balloon and then let it go, it'll start flying through the air, expelling the gas out the little hole of the balloon. And rocket engines work the same way. There are several different types of gas turbine engines used for different applications, whether it be turboprops, helicopters, fighter jets, airliners. It just depends what the need is for the type of gas turbine engine that you're going to use. The most basic gas turbine jet engine there is what's known as the turbojet. These were invented around World War II, used such as the Messerschmitt Me-262, the German jet fighter, and other fighter jets that came online soon after World War II. In those engines, 100% of the airflow goes through the core of the engine, whereas in a turbofan, a part of the air goes through the core of the engine, and a part of the air coming in goes in a duct surrounding the core of the engine. This is what's known as a turbofan. You have a low bypass turbofan and a high bypass turbofan. Low bypass to medium bypass turbofans would be used in such as modern fighter jets, corporate jets, things like that. High bypass, you'll see them on airliners. They get really big. Here's a picture here of a size comparison. This is a picture of a General Electric 90 engine. There you can see the technician. You can get a good perspective on how big it is. In a high bypass turbofan engine, which simply means that most of the air going through the engine is actually going through the duct surrounding the core of the engine, and most of your thrust comes from the air going around the core of the engine, and a very small portion of the thrust is actually coming from the exhausted gas out the nozzle on these type of engines. On aircrafts that use a turboprop engine, the thrust comes from the propeller, but instead of a piston engine turning the propeller, it's the gas turbine engine. These are known as turboprops. The reason gas turbine engines are used to turn propellers for certain applications is because the engine is lightweight in comparison to a piston engine for the same horsepower, and they are extremely efficient up at high altitudes. So you can go really fast and fly really high using a propeller and a gas turbine engine. These engines are typically smaller than a turbofan engine, and the aircraft typically is cheaper than a corporate jet or an airline or something like that. And a turbo shaft, which is used in different applications, but as far as vehicles go, it's used in helicopters, and it works basically the same as a turboprop, but it has a different type of gearbox that's linked to a drive shaft that turns the rotor of a helicopter. And these can also be used in generators for different applications. Now, the reason you would use a gas turbine engine for a turbo shaft or turboprop over a piston engine and not be able to use it as a jet engine is because gas turbine engines operate very smoothly. There's almost no vibration. The parts of a gas turbine engine take a lot longer to wear down than the internal parts of a piston engine, and thus you can go longer intervals between maintenance checks. Gas turbine engines are also a lot more reliable than any piston engine as well, making them safer. Now, the image at the bottom right that says Ramjet, it is a jet engine, but it's not a gas turbine engine. But it operates on the same principle. How it functions is it's already going supersonic. The supersonic air that's coming into the intake compresses itself to go in, and then it mixes with fuel and ignites. The hot gas expands and goes out the nozzle, creating a lot of thrust. These engines are used for very specific applications, mostly military or experimental. These engines are extremely efficient at supersonic speeds, high speeds, high altitudes. But the downside is they already have to be going supersonic for them to function at all. This is not an engine you could light off and take off from the ground. It already has to be in flight. So an aircraft using this engine would have to have another type of jet engine or rocket engine to propel it up to supersonic speeds for this engine to start operating. An aircraft that used a type of Ramjet engine is the SR-71 Blackbird. The reason it was able to take off from a runway and fly so fast and so high is because it also had a regular gas turbine engine for takeoff, and basically it would bypass that engine once it got supersonic and just run on the ramjet part of the engine. The actual gas turbine engine, the core engine, is just a turbojet, and it's actually quite small compared to the rest of the engine nacelle. The simplest engine is the rocket engine, carrying oxygen on an onboard tank to be mixed with the fuel for combustion. This is pictures of the Bell X-1, the first aircraft to successfully go Mach 1 faster than the speed of sound and survive it. This is a picture of the X-15. Could reach speeds of over Mach 5, used during the Apollo missions to put a man on the moon for testing. The space shuttle and the rocket boosters. This is the SLS, or the Space Launch System, for putting objects in space. Rocket engines allowed us to go to the moon and put probes on Mars, but if we ever want to travel to the stars, we're going to need something a lot more advanced than simple reactionary rocket engines. Well, that closes out the video for engines and propulsion systems used in aviation. And I thank you so much for watching. Have a good day.